Today we're going to do some more work with graphing, and graphing in degrees in particular instead of using radians, and also a modeling problem. So remember with graphing, okay, we have an A value that's written right before your sine or your cosine, and that's your amplitude or your height. We have a B value, and remember we use that B value to find our period. So it used to be 2 pi over b, but now we're graphing in degrees, so instead of using 2 pi, the equivalent is 360. So we're going to do 360 divided by b. We do not have a phase shift in these problems. The only other thing we'll have is our k value, or our vertical translation that can move our graph up or down. So for example 1, it says graph y equals 2 cosine of x plus 1 with your x-axis in degrees. So what's an A spot? 2. So our amplitude is 2. So I'm going to make sure on my y-axis I go up 2 and down 2. Okay, my b value. In this problem, we don't have a b value, but how many x's are there? 1. So our b value is 1. So remember, to find our period, we're just going to do 360 over 1, which is just 360. So on my graph, I make my 4 dash marks, and I make sure to label my last dash mark with my period of 360. And a k value. If I look here, no parentheses, but we have a plus 1 at the end. So that means I'm going to shift all my dots up 1 when I go to graph it. So a normal cosine curve starts at its amplitude. So it would normally start here at 2, then touch the x-axis, then hit a minimum, then touch the x-axis, and then go back to my maximum. But instead, I am moving everything up 1. So my first dot at 2 is going to move up instead to 3. My next dot at 0 is going to move up to 1. My next dot at -2 is going to move up to -1. My next dot at 0 is going to move up to 1. And my last one at my period of 360 is going to move up 1. Whoops, that didn't quite follow, but you get the idea. Okay, so the reason we're doing in degrees is when we do modeling problems, a lot of times we have different values that aren't pi on our x-axis. So for this first problem here, we have a bicycle wheel that's 60 centimeters in diameter. Okay, 60 centimeters in diameter. That's going to be important from the top of the wheel to the bottom of the wheel. And it rotates once every 12 seconds. Okay, so it goes all the way around in 12 seconds. A marker is placed on the lower end of the wheel when it starts turning. We need to sketch a graph using a cosine curve and find an equation. Okay, so there's a few steps here. So first of all, we've got a little picture here of our bike tire with its marker. Okay, so here's its marker, and as it rotates, it goes around in 12 seconds. So most of our sine and cosine curves, remember, cycle in fourths. So I'm going to break that 12 into fourths. So here's where it starts, then we're going here, 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 and then it starts and ends at the same spot. So when I break it into fourths, I'm going to be dealing with the 12 seconds total divided by 4. So I have increments of 3 seconds. Okay, so we want to know the height at each one of those times. So my first dot down here is at 0 seconds, and it's 0 off the ground, right? Because it's on the bottom. So that first point is 0, 0. Okay, now 3 seconds later, it's rotated partially, right? So halfway up to the 60 would be 30. So that was 3 seconds went by, and we're at a height of 30 off the ground. Okay, as that wheel continues to rotate, at the top of the wheel, okay, we've gone 6 seconds, and we're up at 60 centimeters. Okay, then as that wheel continues to rotate, we come over here, we're halfway, we've gone 3 more seconds. So from 6 seconds, 3 more is going to be 9 seconds. And notice we're back at only 30 centimeters from the ground. And lastly, just like all these curves, they start where they end. So we're back at 0, 0. But how many seconds have passed? 12. Okay, so we're going to take and we're going to transfer all those points onto my graph. Okay, so I've sketched a curve here. I've got my time in seconds on my x-axis, and I've got my height in centimeters on my y-axis. So my first dot I'm going to plot at 0, 0. Okay, my next dot I'm going to plot at 3, and 30. Okay, that next dot was at 6 seconds and 60 centimeters off the ground. That next dot was at 9 seconds and 30 centimeters off the ground. And lastly, I finished with my 12 seconds and I'm back at 0 off the ground. So this is my cosine curve. Now I need to find an equation that will model this. Okay, so this is going back to what we did yesterday. Okay, in order to find our equation, we need to find our amplitude, we need to find our period, and we need to find our vertical shift if there is one. Okay, so remember to find our amplitude from yesterday. We take our maximum and minus our minimum. So our maximum was up here at 60 and our minimum was at 0. So if we do 60 minus 0, we get 60. And remember to find our amplitude, we always divide that by 2. So here you can see we have an amplitude of 30. Okay. Notice though, this cosine curve doesn't start at the maximum, it starts at its minimum. So really, it's going to be negative 30 for our A value. So we plug that in here, negative 30. Okay, now to find our period, sorry the R got cut off here. So to find our period, remember we take our furthest point on the x-axis and subtract our earliest point. So our furthest point was 12 seconds, earliest was 0, so 12 minus 0 is going to give me my period of my period of 12. Now again, if you remember from yesterday, in order to find B, we take 360 divided by our period. So 360 divided by 12 is going to leave you with a B value of 30. Ironically, 30 both here times. So remember, our B value goes right in front of our X. Okay, now the last part is this cosine curve should have started at its minimum of negative 30, but it didn't. What did it do instead? It started up at 0. So it should have been down at negative 30, but it moved up to 0 instead. So what is our K value? Our K value is also 30. I couldn't have planned that if I had tried. Okay, so our function is f of x equals negative 30 cosine of 30x plus 30. And that is all for today.